In this video, we're going to go over the characteristics of solid, liquids, and gases, and we're going to go really specific. So, when you think of solid, you know that's just something that's like a box or a table or a bed or a pillow. But the formal definitions you have to remember and the formal characteristics are that the particles are going to be tightly packed. The particles have a fixed position, so that means that they only vibrate. A solid doesn't flow. It has the highest density, and they are incompressible. Now let's move on to liquids. Your particles are close, but they can move. Your liquid will flow. It takes the shape of the container. It has a fixed volume, and they are almost incompressible. Now for a gas, your particles are going to be far apart. They move freely everywhere. They flow easily. They have no fixed shape or volume. And they are highly compressible. So, you need to know what the definition of a fluid is. So, fluids are including liquids and they're also including gases. They don't include solids. What fluid means is that they flow. Now, for density, P is equal to mass over the volume. So, that is your that's your variable definition for density. And you need to know that this is an intrinsic property. And what that means is that it doesn't depend on the amount of the matter that you have. Amount of matter, and what matter means is measured in a metric of volume. So for example, you have volume or weight, it doesn't matter. So higher density, so the size of the magnitude, a greater magnitude of density means more mass in the same amount of volume you have. Now, moving on to compressibility. This is how much volume changes under pressure. Your gases, they're going to be very compressible. Your liquids are barely, and your solids are essentially incompressible. Now for pressure, you have the formula P is equal to F over A, force over area. And when you have fluids, your pressure acts in all directions and increases with depth. What is buoyant force? It's an upward force from a liquid. It always acts upward, and it is caused by greater pressure below than above. And it only works in liquids and gases. Not your solids. Your floating rule, and your prime example of this is when you have water, which is ice, is that your object floats if your density of the object that you are examining is going to have a magnitude that is less than the density of the fluid that the object is in. What about flow and viscosity? So flow is going to be liquids and gases, and viscosity is the measure of the resistance to flow. So you can think of a large magnitude of viscosity. High viscosity means that you have something that is thick. Like you have, for example, honey. And an example of low viscosity is, for example, when you have something that's runny, like water. Remember that your density, it does not depend on your amount, and your solid flows but keeps volume, and the solid has no flow.